Hello guys, welcome again. In data structure using Go learning series, today we are on the queue. Today we will learn how we can make a queue and what is the concept of queue using Go language. So here in a diagram it's clearly shown that we have a linked list. This linked list follow the rule of FIFO. If we have a queue, that means queue is FIFO, first in first out. Means if A is the first node, then it will delete first, it will get a chance first. Normally we go anywhere, we have a big queue in a bank or in a market, somewhere whenever we go we have a queue. The rule of queue is first in first out. That person will come first, that go first, it takes service first. So here node A will delete first, node B after that, node C after that. So there is a rule in queue when we perform an operation using any language. Here we are using Go language. So you know that at the head node, head means the first node, the information of the first node, that store the information of front and rear. It take the information of first node and it take the information of last node, the rear. Why? Because the deletion take place from the front end. The front node we use for deleting an element from the queue, and rear end we use for insertion of a new node. Because in queue we have the big O notation 1, because we want to insert a node at big O 1 and we want to delete a node at big O 1. That means only in one operation we want to add a record or we want to delete a record. If here in this example, if I add a new node here, like I want to add a new node, so it will be add from the rear end like this. I have to add from this end. For adding this, the new node would be like, if say this new node is D, then here I have to write a nil, and this nil will be replaced by the D, and this rear will transfer to here. So this node will become rear and we will cut this node. This would not be now rear. So only by the rear we can insert a new node here like this, like this. And if I want to delete a node, that means I have to remove the node A. So I will remove the node A. Now my node front B node will become the front node. So I will update the information of B in my front node, and I will update the information of rear in my rear node like this. So this way we perform the operation in queue. That means deletion from front end, insertion from rear end, and we have the information of front and rear in a head node. And the operation of queue always perform in big O 1 notation, and queue follow the rule of FIFO. That is the main concept to learn for learning a queue. So now we are starting the coding in a Go language here. So we have a package. First of all, package main. Now I just design a function main like this. Now I create a structure and I say type node struct, and here I will create maybe number or int, or we have a node means next node, information of next node in a node like this. One more structure I will have, that is the name of the structure is queue, and here I will keep the information of front and rear. So here I am saying the length of the queue len variable, and then I say that would be the front of this and that would be rear of node like this. Now I have to create an object of this. So I say where my queue like this, and I say address of queue, that is the empty queue creation. Now what I do, I just create an interface. So I say where choice string like this, and I say for true, while the condition is true, I say fmt dot println like this, and I say enter your choice. So I'm taking a choice from the user. Println, the first choice is enqueue. Enqueue is a queue operation for inserting information in a queue. Then we have println, then we have second choice is dequeue. Dequeue is an operation in queue that is used to delete information from a queue. Then we have third one, we can say the next operation is front information, to display the front node. Then we have the size of the queue, and next one, the extra we can print all the information from this queue. So I am just giving a name traverse or display. You can display all information, and at the last we have sixth operation, we have exit. Now we take a choice dot scanl, and here I take choice, and by using switch case I take choice here. If there is a case 1, so I copy, so I paste 2, 3, 4, 5, and last one is default. So this is my 5, this is my 4, then 3, then 2. So what we do, we here exit, last one is exit, so I say os dot exit, and here I pass 0. Now I create the function for this. So my queue, so first of all I create a function enqueue. So here I say my queue dot enqueue, and here I have to pass a number. So this function I will create, and then I say my queue dot dequeue, this function I will create. Then third choice is front, so my queue dot front, that function I will create. Then fourth one is size, so my queue dot size, that function I will create. Last one is my queue dot display, that function I will create. So all these functions I will create, and in enqueue I have to take a choice also. So I say data string, I say fmt dot println, I say enter number that we want to insert, enter a number for node in queue. Okay, then we take scanl for input data, then I convert this data into string into number like this, and I pass the number to this function. So this operation, this input, taking input from the user is complete. Dequeue, enqueue, front and size. Now I have to perform these operations. So first operation, the first function or method that I want to create here, that would be, I say head and I say queue like this. I say enqueue. Here I just put a number this way. So head is here. So I create a new node here where I say temp equal to node like this. So I create a node 1 first, then I say temp dot num equal to number equal to num and temp dot next equal to nil first time. Now I say if the head dot front equal to nil and head dot rear equal to nil, that means both are nil, that means there is no node inserted, then head dot front would be the temp, head dot rear would be the temp, both will be the temp. Else then head dot rear dot next would have a temp and head dot rear would have a temp. You see, the next node will point to the temp from the rear next time, and this rear, because insertion take place from the rear end, so I will replace the rear with the temp. So temp would be the next rear node, and after that I say head dot len plus plus. So length of this would become here. So this is completed, I think. Now second function, we have to create one more method, that is dequeue. So we say head here, then queue, then dequeue like this, and here we delete from the front. So if I say head dot rear equal to head dot front, both are equal on same address, then head dot rear equal to nil and head dot front equal to nil. Okay, else head dot front equal to head dot front dot next. So we are removing the first node. Now next node will become the front, and we say head dot len minus minus like this. Okay, now we have a front function, so I have to create front one. So I say func head queue, we have a function front like this, and now I say fmt dot println, and I display here that front node is, and we can write here head dot front dot number, like this. Okay, so it would display the front node. If we have a size, so I say func head queue, I say size fmt dot println, and I say size of queue equal to head dot length. Okay, now we have to traverse last one, that would be display func, then head, then queue, then display, then we have a node where p node equal to head of front, like this, and for p not equal to nil, fmt dot println and printf, and I say the queue percentage %d like this, and I say p dot number and p equal to p dot next, like this. I think all operations done. Now time to test the program. So I just clear screen and I go to this folder and I say go run queue.go, and if I run this program, I have an option to enqueue. So first element is to insert 34, then second 89, then third 56, and we have a 5 operation to see the information. You see we have a information, so insertion take place from the last, so 56 is the last element. One more element I want to add, I say 90, and if I travel once again, so 90 is the last one. So deletion take from the front, so if I say 2, that means 34 will remove. I display once again, so 34 remove, it gone. Once again if I say 2, so that means 89 will remove, and front, so third choice was front, but I say 5, so that means 2 elements are there. One I press and I insert 60, one more element I press and I insert 50, and I display. You see now 56 is the front, so if I want to see the front node, I say 3, so 56 will display the front. If I want to count the size, so there are 1 2 3 4 element are there, so I say size 4 choice, so you see the size of the queue equal to 4. So everything is running perfectly, and we have performed the all operation of queue here, and I say 7, so it will remove from the queue. So you have seen that how we have implemented the queue by using Go language. Simply just we have performed all the operations of display, size, front, dequeue, enqueue, all the operations we have performed. Just remember that insertion take place from the rear end and deletion take place from the front end. So that was in this video. If you really learn anything from this video, kindly do subscribe my channel. Thank you for watching this video and see you for more videos. Those are coming in future. Thank you.